Good afternoon, everyone. First of all, I would like to welcome everyone in the room today, the ones that made the most smart decision today to ignore the rest of the sessions and come to the most important session in the day. Well done. So, and also I can't actually forget to say big thank you for Arsene and the rest of the organizers of this great event. I had the pleasure that I was actually here last year, and I can see the significant progress and difference in the hydrogen story, not just in when it comes to the conference, which is still a big image for what's happening in Morocco when it comes to the hydrogen, but also about the good progress that Morocco has made in this industry so far. 2 years ago, the talks were mainly about plans, ambitions, the country and the different potential players at that time had for Morocco to play in the global and regional hydrogen space. And some discussions about potentially pilot projects. Year later, last year, the discussion was mainly about hydrogen strategy, national hydrogen strategy, potentially starting building pilot projects. And guess now, since then, Morocco started building 2 green hydrogen / ammonia projects, or in the process to do so here in Morocco. And now the discussion is about a mega scale, 1 million ton of ammonia a year, again, here in Morocco. For me, this is a significant progress, I can tell you. So well done. And I'm very confident, especially seeing what's happening in the international hydrogen market and how this is growing, that Morocco will take further a step to strengthen the country's position in this space. I had myself the privilege that I've been in this industry for so many years. The first blue ammonia plant I built was back in 2010. And then worked in the electrolyzer side with IT Empower, and then as a principal consultant for the world's first larger scale green ammonia project in the Middle East. And now I'm with a business called the Chart Industries that we do hydrogen liquefaction, hydrogen compression, technologies and storage solutions. And I can tell you the story of the hydrogen and the progress that the market has made is completely different than what we thought, it will happen just 3 or 4 years ago. I remember 5 years ago, I was in somewhere near Birmingham in UK building what it was at that time, the largest green hydrogen plant in UK, 3 megawatt. And everybody was like proud of being part of the story. And someone from one of the technicians asked me, Salah, what do you think will be the largest scale moving from 3 megawatt to how many in 5 years' time? I don't know why he picked 5 years' time, but we are 5 years' time from that date. And I told him, based on some solid discussions with the major hydrogen projects developers and the players at that time, that probably 20 megawatt. If we will be lucky, maybe 25 megawatt. But guess what? With the climate change issue, unfortunately, with what happened in Ukraine, the story of the hydrogen has now totally different flavor. And now, instead of 25 megawatt, that was the expectation, we see Shell talking about a 200 megawatt plant in the Netherlands, a project that already passed the FID. Air Liquide, 2 projects, 300 megawatt, 250 megawatts in Normandy, in France, and in Phoenix, and in the US. Even Sinopec in China, just about to start the production from a 250 megawatt project out of China. Even the business that I'm presenting today, Chart Industry. So when we kicked off the initiative around our a business in the green hydrogen side 3 years ago, frankly speaking, even a number of our executives were against the idea. And guess what? The size of our business now, as a technology provider, as an equipment supplier, is 9 times what it was less than 2 years ago. And I'm sharing this number because I think it is really very important to share some actual numbers. The market is there. The market already started, and the opportunities are there. Not just our business, but other companies have started to make a good business out of this, what people like to call so far challenging market. And I'm sharing this message for everyone, and in particular Morocco, really to encourage you to complete the journey that you have started, because again, the market is there. So today, we'll be talking about one of the key, definitely, subjects and issues as well for in the hydrogen industry, which is the hydrogen carriers. As we all know, there are markets that need the hydrogen, but unfortunately can't actually produce it in an effective way. So there is a need to link the production market to the consumption market. And with the challenges that we know about transporting the gaseous hydrogen, there is a need in the short, medium, and long term to come with the solutions. And the solutions probably will be different on those phases. And one of these solutions indeed is transform, to convert the gaseous hydrogen into another molecule that we can convert back, whether convert back into hydrogen in the where we will consume the hydrogen or the carriers, or use them directly, ammonia, e-methanol, e-fuels, and others. And this is basically will be the main subject of today's session. I'm pleased really that we have a good mix of hydrogen experts that their profiles cover very well the hydrogen ecosystem and the hydrogen value chain. So I would like to welcome to the stage Ms. Fatima Al-Zahra Filali from Mazen. Thank you. Benedict Heuser from FEV Group. And last but not least, Jochen Bard from Fraunhofer. So as you can see, we have a mix of R&D. This is where everything starts, right? And I know Jochen, yourself and the entity you're presenting today have been actually for years involved in key studies around the hydrogen and the other carriers, helping your partners really to figure out what is the best way to move the hydrogen molecule. And then we have the engineering consultancy represented by FEV Group. So it is the more of moving the conceptual ideas into industrial scale. And last but not least, Mazen, definitely will know a name, project developers that close actually the cycle. So with this, I think the structure of the panel today will be more of having 2 presentations linked well to the subject, and then we'll have the rest of the time a per panel discussion, and we'll leave, if it's okay with everyone, 5 to 10 minutes for the audience to answer, to ask any questions, and my esteemed colleagues here today will do their best to answer these questions. With this, Fatima, if you don't mind, you can cast. Thank you. You can use it.
Hello, everyone. I am Fatima Zara Filali Bokhres. I am from Mazen. So I worked as a project manager for novel technologies in the development team for floating PV, offshore wind, and waste energy. And actually, I'm project director of reference projects P2X jointly with KfW. So thank you a lot. I'm very honored to be part of this panel discussing a key topic of the hydrogen value chain. So the next slide, please. So before digging on the more on the topic, let me say that we have a problem. We have a mismatch between the site locations where we have the best cost effective, where we can produce hydrogen, green hydrogen in a cost competitive, and the demand centers. So as you see here in the map, so in the green map, so in the green countries, we have North Africa, which represents a very high potential to export green hydrogen to the closest markets. It's clearly shown, I don't have laser to show you, but a large arrow linking North Africa with Europe. Next, please. So I will give here some numbers. So North Africa only could represent for the global export potential, represents 40% of the global hydrogen exports, generating around 110 billion US dollar of revenues per year, over 280 yes, US dollar revenue per year. Focusing now on Morocco. Yes, so there is a lot of panel talking about cost competitiveness of green hydrogen on Morocco, thanks to our resources, high potential of renewables, and also the high capacity factors. But also we have a large volume that could be exported to Europe, exceeding largely the local demand. So, but all these advantages for Morocco, but how can we transport this hydrogen to Europe or to the closest markets? So this is the big question. So for instance, the most suitable solution, we think, or we can say that it will be pipeline. But with a big B, pipeline needs a huge initial investment requiring, or it could be only justified if we have a large volume of hydrogen to be traded or to be transported. It's require also a huge and big commitment of different stakeholders, and also a lengthy deployment timeline. So what are the other solutions, as already introduced by Mr. Salah? So we have delivery carriers. So let me start with the liquid hydrogen as a carrier. So it represents, we can say that it has a much higher volumetric density than the compressed one. So it represents a big advantage. So we can transport the same quantity, but in a less volume. But the liquid hydrogen represents different barriers. So first, the main challenge is the cryogenic temperature of hydrogen to be liquefied. So it needs expensive equipment to be transported, handled, and stored. So this requirements or liquefaction process requires 30 to 36% of the energy contained on the hydrogen itself. Second point, liquid hydrogen can be transferred only where terminals have some specific facilities like liquefied storage and also regasification facilities. So it could limit the number of potential off-takers. And thirdly, liquid hydrogen pure shipment is not yet fully commercialized. There is limited project in operation of for the international regular trade. For example, we have the project linking Australia in the ports of Victoria to Japan in Kobe. So to date, we can say that liquid hydrogen appear as a niche. Moving on to the LOHC, liquid organic hydrogen carrier, it could be transported as any other petrochemical product, so great. This is a good advantage. But despite this good advantage, the production for the LOHC itself, it needs several steps and heating process consuming a lot of thermal energy. So this process can require between 35 to 40% of the energy of the hydrogen itself. This is the main concern associated to the use of LOHC as a hydrogen carrier. So we have the transports, which is good, but in the other hand, we have the production, which is not fully commercialized. On the other hand, we have two good candidates, as I can say, good candidates for hydrogen carrier, which are ammonia and methanol. So ammonia, it could be defined as the most mature and cost-effective carriers available for long-distance trade. So when we compare it with liquid hydrogen, handling ammonia needs much higher temperature. So it needs -33 degrees to be liquefied in compared to liquid hydrogen, which need -253 degrees. Yes, which is greatly simplify the containment of ammonia and also reduce transport losses. Ammonia is also one of the most widely utilized chemical and benefits from an extensive and existing terminals for importing and exporting worldwide. So in terms of logistics, so domestically or international, handling ammonia practices and supply chains are extremely mature and well established. But despite this advantage, the main challenge of ammonia is the ultimate utilization of ammonia. This is the big question. So if ammonia is transported in the intention to be cracked or reconverted, cracked and converted back to hydrogen, so and even when the terminals have the required facilities in both ports of trade, so the reconversion process impacts hugely the investment costs. So the typically ranging from 25 to 35% of the overall investment needed at the importing and exporting ports. So this is a big challenge for ammonia in the ultimate use. And finally, now I would like to draw the parallel with methanol, which also represents a strong carrier due to its stability to be handled, transported as a liquid state under ambient temperature and pressure conditions. It can be handled, stored, and transported also easily in the existing infrastructure that supports the global trade of methanol. However, with a big H, methanol, along with other carbon-based derivatives, need carbon source, as you know. So the requirements of the carbon source are defined in a regulatory framework and different countries and are very complex. I will say here an example to illustrate. So the red 3, it allows different sources of CO2. So it allows CO2 from fossil industrial point sources, but it's permitted only until 2036 in the case of the energy generation. The second source, it could be CO2 from biogenic carbon, such as biomass, which is very good, but are very rare and scarce. And the third option is the CO2 by DAC, extraction from the air. Very good, the air is available, but the technology is energy intensive and very expensive. So it's require around 700 kilowatt hour of electrical energy plus 2,200 of thermal energy per ton of CO2. So this is the main challenge for CO2 as a carrier. So as I can summarize, all these chemicals and hydrogen carrier are definitively much easier to transport than hydrogen. Yes, it's confirmed. But their opportunities and barriers vary across the value chain. So while one option, it could be the most suitable for one part of the value chain, for example, for the production, there is no barriers, but in the other hand, it could be offset by higher costs of transport or technology complex in the other hand. So the decision to select the final product is not depending only on technological aspects or transport handling, but on also other parameters such as offtake requirements, needs, and location. So finally, to conclude my my speech, I would like to draw a parallel with a renewable energy sector in Morocco. So the development of a global green hydrogen and its derivative in Morocco share with renewables some parallels. So particularly, they share the goals, drivers, and benefits. So the development of renewable energy in Morocco was achieved through the creation, what we can say, enabling environments. So we establish regulatory, we create institutional frameworks, and a strong commitment of different stakeholders and the favorable climate for investment. So now we are currently living the same fundamental shifts where green hydrogen will inevitably play a crucial role in achieving the net zero goals. So all these elements provide us with a strong motivation to act swiftly. So get to work and fast. Finally, to conclude, so I have two key messages that I would like to share with you. So there is no net zero without having regulations, infrastructures, and enabling environments. The second is off-takers have significant role in the selection of the hydrogen delivery carrier and also in shaping hydrogen market dynamics. Thank you very much.
Thank you, Fatima. Thank you very much. So now will Bendik start next with the presentation about one of your coming projects. Thank you.
So, thank you very much. Welcome also from my side. It's an honor to be here. For me, actually, the first time that I'm here. I missed the last 2 years. My name is Bendik Teuser. I'm Group Director at FEV Energy. Today, talking about the water project, waste to energy, and I'd like to discuss how to actually produce green methanol in Africa. And Fatima, with many of your statements, I do fully agree. With some, I do slightly disagree. And thanks for breaking the ground for this discussion. But first of all, who actually is FEV? FEV, we are an engineering service provider founded around about half a century ago in Aachen. Right now, we are a little bit more than 7,300 colleagues with a very strong academic and international background. We do have about 40 different subs in five continents. Also here in Morocco, in Casablanca, we have an engineering center and test center with about 150 colleagues working for us. What do we actually do? For our customers, we're doing full vehicle development, we're doing full powertrain development, so BEV, ICE, fuel cell, hybrids, pretty much everything what you can think of for all kind of applications. Within FEV IO, we're doing software development, so ADAS, car-to-car, car-to-X communication, very much for the automotive and mobility sector. Within FEV test systems, we are planning, we are building test systems, test field automation systems for our customers and clients. And we do also have the FEV consulting branch. I'm here today representing FEV Energy. And within FEV Energy, we're pretty much tackling the whole energy system. Starting off with energy management systems for stationary applications, but also doing electrolyzer development, electrolyzer testing from component to system level up to the megawatt scale. And of course, we're doing project planning, conceptual layouting, feasibility studies for power takes and B2X plants. That should have been taken. Can you go to the next slide, please? Next. Yeah. So Fatima, you mentioned some of these facts already. If we're talking about green hydrogen carriers, methanol, of course, is one of the very promising candidates. Let me briefly tell you why. The renewable energy carriers or hydrogen carriers shall be cheap to produce, cheap to store, and cheap to transport. And in best case, they are also applicable for many different sectors and use cases. Methanol fulfills those requirements very much well. Yeah, so as you said, it's liquid at ambient temperature. You can rely on a globally existing infrastructure. It is a globally traded commodity with more than 120 megatons worldwide already. And you can scale down methanol synthesis quite easily and still be economically viable. And that makes it easier to also exploit locally low-cost, decently available carbon sources. And for that reason, we think that methanol is really one of the key players in future. If you go to the next slide, please. So that is pretty much why we also started thinking about how a green methanol factory can look like. And for us, it's been important to really minimize the risk for the investors, meaning start off with rather small facilities, low capex and low opex. And that is pretty much the very, very simplified sketch of what we came up with. Yeah, so you said carbon sources are limited, biosources are limited. We take waste. Yeah? So sewage, sludge, manure, that is not a limited resource. Yeah? We produce each and every day more and more and more of that. So definitely unlimited. That sewage, sludge, and manure is then treated hydrothermally. And by that treatment, we're getting clean water. We're getting byproducts like phosphates, metal salts back from the sludge. The water can be used for agricultural purpose, for instance. The gas streams of hydrogen and carbon dioxide are fed into the methanol synthesis. So by this manure treatment alone, the stoichiometry of the hydrogen and CO2 feed does not really match to the requirements of the methanol synthesis. And for that reason, we're also employing renewable electricity generation for this facility around about 50 megawatt. And that is going to power the electrolyzer unit to have more hydrogen available for the methanol synthesis unit to really maximize the output. If you would go to the next slide, please. So now you could ask with whom we're doing that. Our main partners are listed here on that slide. Many well-known and globally active companies that are providing the technology. All the technology we're using is at least a TRL 7. Many of the components you actually can buy off the shelf from the suppliers, and that really makes the technology or technological risk of the whole installation rather low. And on the next slide, you can see the social economic benefits of the project. I guess most of you are familiar with the United Nations sustainability goals. Some of them you can also find on that slide. So we are disposing waste in the facility. Yeah? So we're disposing waste, creating higher value chemicals. We're providing clean water to the region, mainly for agricultural purpose. We're creating, with each of that small scale facilities, about 60 value-created jobs in the region. And the environmental risk is also rather low because methanol is biodegradable. It's not very explosive. And for that reason, we really create a socioeconomic benefit for the region where we're employing that facility. So now on the next slide, you can see that, of course, we are that not doing only for altruistic reasons. There's also business behind. What you can see here is now some of the key figures of the business case for the very first green methanol plant we want to install. The FID has to be taken by end of this year. It is quite mature, so we do have offtake agreements for the methanol. We do have agreements with the land provider. We do have concessions for PV, etc. So we are on a very good track. I'm not going to each and every number of the table, but what's remarkable, with that facility, the investor is able to get a positive cumulated EBT even 3 years after SOP. So very, very fast. We have double-digit margins right after start of operation. And that is mainly for 3 reasons. First, we do really limit CapEx and OpEx for installation to about 100 million euro investment. So that's rather low. And the reason for that is that we skip costly hydrogen storage. So we do not have an oversized PV field or electrolyzer to really have the hydrogen storage for night times. We do store CO2 that is available during summer and during daytime. And CO2 storage is way, way cheaper than hydrogen storage. Second reason is for OpEx, we take bio-waste. So bio-waste is also very cheap. In fact, the waste treatment companies are happy if there's someone who just takes it from them, so they do not have to care about any disposal. And third, and for this very project, a very, very, very important fact, we do get a grant from the German Ministry of Economic Affairs and Climate Change. The grant in total is 30% of the capex, meaning up to 30 million euro. We do have quite high security that this grant will really be granted. It has not to be repaid. It's interest-free, and that really significantly boosts our business case. The main investor for that project is eFuel GmbH from Germany. But if you think, hey, that really sounds interesting what they're planning, feel free to reach out to us if you jointly want to build that facility with us in Tunisia. On the next slide, you see different case. If you now think that the technology, it seems really to be interesting, but I would rather like to get things going here in Morocco. Then I might also have some good news for you, because actually next Tuesday, a colleague of mine, Usama, who's general manager of FAB North Africa and FAB Morocco, is going to meet with Irefin, with Ayub in Frankfurt. Nareva will join, and also the German ministry again, to set up a case how to actually also get these facilities on the ground in Morocco. For that, we are also going to even larger facilities. So we're going to include dry biomass via gasification. We might also include direct air capture as kind of research topic. And with that, we think we can get up to in the 100 kiloton range. So still, that is biomass. It's renewable energy carrier. So we will, with that facilities, not go within the 1 million ton range. So overall, that type of facilities are rather a numbering up than a scale up. So with that, I hope I'm still in time, Salah. Thank you very much for your interest, and I'm happy to take your questions. Thank you.
Thank you very much for the two presenters. Fatima, I think you offered a good example of how our women in hydrogen should be very knowledgeable. Thank you very much. Benedict, very informative presentation. Definitely have myself a few questions. But before jumping actually to this, I have to say that also I'm pleased to have somebody from Fraunhofer with us. I think I've been always a fan of Fraunhofer and how over the years you have been actually supporting different industries in the old days, power, oil and gas, definitely. So Jochen, I have a question. First of all, if you don't mind, maybe you can give a quick introduction about, first of all, your own personal journey in the hydrogen space. And then maybe you can shed some light about, what Fraunhofer have been doing in this space, especially when it comes to evaluating the different rules that the different hydrogen carriers can play in this space, if you don't mind.
Yeah, thank you very much for the opportunity and your kind introduction. And my name is Jochen Barth. I'm the director of the research division on energy process engineering and energy storage at the Fraunhofer Institute for Energy Economics and Energy Systems in Kassel in Germany, which is part of the Fraunhofer organization with more than 70 institutes. We have a total of 30,000 people, so which makes us the largest applied research organization in Europe. Now, hydrogen is a big topic. We have a hydrogen network within the organization that involves almost a third of the institutes, covering a whole range of different activities. Within our institute, we have two main research topics. One currently is the electrolyzer technology as such. So we do a lot of laboratory analysis of electrolyzer cells, characterizations in order to inform simulation models, which eventually allow us to do calculations of the degradation of the systems, which is quite an important topic now. And the second technical research element is the power electronics. The inverter is the second most expensive component in an electrolyzer after the stack itself. And for the large-scale electrolyzers, there is a lot of room for optimization of the power electronics. Other than that, we are working on techno-economics of Power-to-X projects. I have to say that the very first project, green hydrogen project I ever did in my career was actually in the year 2000 in this country, in Morocco. We had a European project to design a village electrification scheme with PV and wind and hydrogen as a storage pathway, together with Professor Abdelkader Utzurit from Qadi Ayad University here in Marrakesh. He's in the conference, but I'm not sure he's in the room today. So that was the starting point for my hydrogen or green hydrogen projects. Nowadays, we are working in I think it's 8 countries with at least 15 different projects of all scales, in the hundreds of megawatts for the larger ones. As part of the study work we are doing, we have tried to understand in the scenarios for the decarbonization of the European economy, what is the role of hydrogen in the future. And what it boils down to is that from the hydrogen demand that we are seeing in Germany and in Europe, only about 1/3 will actually be hydrogen at the end. The 2 other thirds will be the derivatives that we have already heard about, things like ammonia, methanol, ethylene, and so forth. Having said that, it means that for importing hydrogen as hydrogen, there is only a fraction of the total hydrogen demand needed. And there is, of course, the benchmark of importing hydrogen via pipelines from the neighboring regions. That has been addressed repeatedly throughout this event. And then the question is, what is the role of the hydrogen carriers? We did about 2 years ago a very extensive study for the European Commission about import options, technical and economic import options. And we looked into all the different pathways of carriers. You mentioned almost all of these carriers already in your introduction, Fatima. So there's not much to add to which topics, technologies are we talking about, but there is even new ideas. For example, DME, which is somewhere in between ammonia and methanol. And the idea is also that you can use the same tanker, the same ship to return the CO2 from Europe to wherever you are producing your DME. So there are a variety of advantages and disadvantages for all these different technologies. When it comes to efficiency and cost, they are not that different. We typically have like maybe 5%, maybe 10% difference in the efficiency overall for the transport. The cost, of course, can be significantly different, but that also depends on things like scale. And when you choose a transport option and you are thinking of carriers, typically you will not install the necessary infrastructure only for the hydrogen carriers. In the case of Morocco, for example, with one of the largest fertilizer manufacturers in the world, there will be a lot of ammonia trading going on, a lot of ammonia supply. That means there will be an ammonia infrastructure. And in the shadow of that, you might want to export green ammonia to wherever in the world. And here the benefit over a pipeline is that you do not have the same location all the time. You're not depending on that pipeline and your client sits at the end of it. With ammonia shipping, you can deliver to whomever you want to, but you might not want to introduce the ammonia infrastructure only for exporting hydrogen. But in the shadow of the green ammonia, which is used for fertilizer, for example, it might make sense to go down that route. And that is the same for the other carriers as well. Methanol has a whole range of different applications as a fuel, as a basic chemical and so forth. So if there is a scaled methanol production, it might also be worthwhile to export methanol to off-takers who are cracking the methanol if there is a business case for them. So that's my view on the hydrogen carriers for now. Thank you.
Appreciate it, Jochen. Thank you very much. Very interesting. Jochen and I spoke yesterday and really appreciate again the role that Fraunhofer and entities like Fraunhofer actually plays with their ability as independent, more of a consultant, can give and unbiased advice in this project. If you spoke to a business or a company or entity involved in the ammonia space, definitely the answer for the hydrogen carriers be definitely the ammonia, not a surprise. Liquid hydrogen will be the same, but again, having somebody involved in these studies and projects like Fraunhofer offers really a great value for sure. Bendig, I would like to move to you. I mean, thanks again for the very nice and informative presentation that you gave. E-methanol in particular definitely expected to play a role, especially in certain segments. We heard recently, a few days ago, actually, about Maersk plans to use the e-methanol in the marine study as well. With that being said, do you see any challenges for using the e-methanol as a hydrogen carrier? Especially, I heard a lot about that one of the many challenges could be also the source of the CO2, having enough CO2 in the game that can help you to scale up your project. It will be interesting to hear your thoughts.
So as Jochen just said, the market uptake for renewable methanol is significantly, yeah. So there are studies that saying within the next 30 years, we're going to up to 400 megatons renewable methanol. Today, we are pretty much zero. So the market uptake is massive. The concept I just showed, scale up is possible. Yeah, so that's, as I said, pretty much kind of numbering up. You can go to, as I said, with that type of concept, maybe 100 kilotons, but still always if you're taking concentrated carbon sources, you're just limited from where you actually get it. Yeah, then the next step would be when that might be economically feasible, really DAC whatsoever, but then still you need extremely large facilities. Yeah, so the imagination that some people have that the renewable energy carriers will be produced in same scale facilities as we do today, like GTL or whatsoever, I think that will never happen. What we are currently actually investigating is if you have kind of bulk carriers that are traveling along the coast, for instance, yeah, and then really take up whatever 10,000 methanol here and then the next 50,000 methanol over there. And then by that, you can fill up the large tankers that can go to Hamburg, for instance. Because Hamburg, Rotterdam, you name it, all the ports and harbors are tried to also get greener and to become the central hub for importing renewable energy. And in fact, the methanol, what we are going to produce now with the green methanol factory, that is also shipped from then Tunisia to Hamburg and then further produced. And you said Maersk, MAN, Wärtsilä, they're all producing large two-stroke methanol engines already. The first cargo ship running on methanol was just inaugurated. So there will be a future for sure.
So, Fatima, I definitely can't forget to ask, having you here in the panel today, the ammonia and the Morocco, right? Two close words nowadays when it comes to the hydrogen in Morocco. But really very keen to understand where Mazen is when it comes to, I assume, the study that you have done to evaluate the different potential carriers that the business will support. Have you, let me put it in another way, have you decided that you will support just a single carrier of those, or are you in the process of doing so? Especially that I understood also that you have been working and you're still working with a number of partners really to evaluate such options.
Yes, thank you very much, Salah, for this interesting question related to the reference project. So what I can say is that, of course, internally, we have conducted our own internal analysis. We have analyzed all the most known delivery carriers, but the ultimate selection of the final delivery carrier will be driven by the off-taker itself, by its preferences, but its requirements to meet their goals and its needs. So we look forward to make a collaborative decision. Not only Mazen will decide for this delivery career, the most suitable is this one or the other one. No, we are looking for a collaborative decision with a future Mazen partners, which will be the co-developers and the off-takers, to select, of course, the most suitable hydrogen delivery career. And the final decision, it depends, it's by projects. We cannot say this is the most suitable one for every project.
Interesting, yeah, and makes a lot of sense. Absolutely. I mean, this.
Thank you.
I agree with you. This has to be linked to also the off-takers, and that who also decide on which carrier actually that they would be interested to use. With this being said, also, I mean, maybe question to you, Jochen, if you don't mind. The ammonia. How do you see the ammonia? How do you see also the challenges and the opportunities that the ammonia have in this space when it comes to the production, the cost, as well as also probably some safety concerns, whether questionable or not? But we saw lots of people actually raising these questions, more of a concern when it comes to using the ammonia as a hydrogen carrier.
Yeah, thank you for that question, Salah. I mean, as Fatima already pointed out, ammonia production at scale is something that is done with, what is it, more than 100 million tons per year, and 20% of that roughly is actually being shipped. So there is an established supply chain. We know that the procedures. Of course, there is a switch to green ammonia, which will also lead to some modification in the way that we produce the ammonia. If you look at the technical details, but the main challenge there is, of course, the cracking. If you are talking about a hydrogen carrier here, there are first plants under construction now, also in Germany, or we then have to see whether there is a business case at the end of the day. We've been there before. Now, the other thing with the safety aspect is, of course, that ammonia is not the easiest commodity to transport. It's highly corrosive, and you need to set up your ship tankers and all your infrastructure for that highly corrosive liquid. And secondly, it's also very toxic. So in the case of a hazard with a ship, you're running into some serious environmental issues. You can, of course, increase the safety of the tankers in order to meet the highest standards, which is currently happening with the most modern ships. But there are, of course, issues with those kind of things, or challenges and risks involved, which are not at the same scale with the other carriers. So even though we have the supply chain in place, we have the technology in place, it's still a significant effort to scale it up. And as I said before, there is a lot of ammonia demand as ammonia for fertilizer production and a few other applications. And whether or not there is then the business case and there is let's say, an opportunity for using it as a carrier, we have to see. I personally am not convinced at this point in time that we will see very large quantities, or that ammonia will become the leading hydrogen carrier for global trade.
Great, makes a lot of sense. Thank you very much. See somebody waving. So I think as the rest of the sessions, we can definitely keep going and talking and discussion, but I would like to leave 5 minutes for any questions in the room. So for our panelists really to answer. Okay, so if not, then actually I have a question, Benedict, if you don't mind. I've always been actually interested in knowing the real numbers for the project that you kindly actually showed to us. Roughly how much this would cost from the capex point of view?
When we're talking about levelized cost of methanol, I'm afraid that I'm not going to tell the hard numbers right now to everybody. I'm happy to discuss that bilateral with you. What I can say is during the first 10 years of amortization of the facility, we are well below 70 cents, well below. After 10 years of amortization, of course, we have some reinvestment in the electrolyzer, but still at that point in time, we are well below 50 cents per liter, well below. Yeah, that is, I said, no hydrogen storage, so lots of capex is just not there. The cheapest carbon source you can actually think of, it's waste, you get it almost for free, and that all combines to quite low costs of the final product then.
Quickly, Jochen, as well, maybe in a few seconds, your view in the LOHC. Definitely, we can't actually overlook in this the discussion. How do you see this as or the potential of this carrier in this industry?
Yeah, well, again, Fatima has already explained that you need heat for the hydrogenation and dehydrogenation. You need to have a heat exchange, and it's substantial amounts of heat. But the main challenge is actually to scale the production of the liquids itself and which to choose. So there is, I would say, still some economic risk in for which you would go. Once you have the liquid, of course, it's easy to handle, but the cost of the liquid are, if I remember correctly, in this is similar to the cost of the ship. So it's a very significant investment into making these liquids. They do have degradation also. So with each cycle, you have a bit of degradation. Yeah, there is still a lot to learn and understand about scaling, how to scale up the technology and whether or not we will succeed. For me, that's not not yet decided, to be honest, but it is an interesting solution with, again, with a trade-off in applying it.
Great, thank you very much, Jochen. So I think we're over time, but I think, I would like, to thank all the panelists for this very fruitful discussions and the insights and the solid examples, real world examples that they have shared with us. Clearly, I think if I would conclude I will conclude with a high level statement that the energy transition is something that we need to work to achieve as soon as possible. And I think this makes it very important to be flexible in the first place and open the door for all the potential carriers that we know that every one of them will play a role in the energy transition. I'm always saying that answering this question, which carrier will take the lead, it is a question with maybe 3 or 4 dimensions, not one dimension. There is no silver bullet here, right, Jochen? As we spoke yesterday. I think it's a matter of what application the carrier will serve and where we are going to produce it, and also when. So the solution that will work in the short term, in the next 5 years, probably, we'll have a different answer in 10 years' time. And in 30 years' time, the picture will be completely different. So thank you all for the discussion, and thank you all for your time today. And please, if you have any questions, I'm sure you can reach out to my esteemed colleagues here, and look forward for the rest of the sessions. Thank you very much.